The purpose of this film is to give you a general survey of what has to be done to a bomber when it returns from one operation in order to prepare it for the next, with particular reference to the armourer's duties. On landing, the pilot will first taxi his aeroplane to its dispersal point. Dispersal is the name given to the system of keeping aircraft and other equipment spread about the aerodrome so as to offer no concentrated target to the enemy. Having parked their machine, the crew go off in search of well-earned rest and refreshment, and to make their report to the intelligence officer. As soon after dawn, as may be determined by the needs of the moment, the ground crew begin their task of preparing the aeroplane for its next operation. First on the scene is the refueling squad, for all aircraft must be kept with tanks full, ready to take the air as quickly as possible in case of emergency. Furthermore, a supply of fuel and oil will be needed for test purposes. Any bombs which may not have been used are removed by the armourers, and in accordance with the schedule of whatever inspection is due, fitters examine the engines and make any adjustments, repairs or renewals which may be necessary. Riggers go over the bodywork looking for signs of wear, oiling working parts, seeing that hydraulic reservoirs are topped up and systems are free, and also searching for any damage caused by enemy fire. Photographic equipment, which is used to record the effect of bombs dropped, is reloaded with film and replaced after thorough servicing, together with the appropriate photographic flares. Owing to the height at which our aircraft operate, a quantity of oxygen is used by the crew on each flight and must therefore be replenished after every operation. These oxygen bottles are liable to explode, with fatal results if dropped or knocked. At some aerodromes, maintenance of aircraft guns is carried out by armourers, at others by the air gunners themselves. Guns are cleaned daily, the recoiling portions being withdrawn for this purpose. First, the gunner detaches the hydraulic control to the gun sear. He removes the back plate. The recoil spring is removed, and by means of a wire toggle affixed to the cocking stud, he withdraws the breech block. The gunner now releases the spring plunger of the lock frame and withdraws this and the barrel and barrel extension from the gun. The guns not having been fired on this particular operation, they merely need pulling through with the cleaning rod to which is attached a piece of very lightly oiled flannelette. He returns the barrel, barrel extension and lock frame to the guns, preparatory to checking guns and sights to see that they are harmonized. For this purpose, he trains the sight and guns onto a reduced scale sighting board. First, he trains the turret on the sighting spot on the board, and then checks the alignment of the guns on their respective right and left-hand spots by looking through the barrels and the sight. Meanwhile, in the ammunition filling room, machine gun belts are being prepared by means of the belt filling machine. This automatically inserts the rounds into metal links and roughly positions them. The rounds are put into a hopper in the proportion of different types of ammunition required for the operation in question, that is, day or night. These will consist of ball, armor-piercing, and incendiary. In order to apply the tracer firing principle, a percentage of tracer ammunition is put into the belt, accurately spaced every so many rounds, approximately 1 to 5 of other types of ammunition, as can be seen here. The actual percentage of tracer depends on the number of guns and the individual turret installation. The belts are carefully wound in order to avoid damage or distortion to the belt links, which, if not eliminated, would cause gun stoppages. Belts are now passed through the belt positioning machine which accurately aligns the base of each cartridge in relation to the links forming the belt. The finished belts are carefully paid into spare ammunition boxes for easy transport to aircraft. From the boxes in which the ammunition is carried to the aeroplane, the gunner now carefully transfers the belts to the ammunition tanks in the turret. When the tanks are full, he threads the ammunition by means of a toggle through the ammunition chutes into the feed block of the gun, ready for loading. The aeroplane having been subjected to the appropriate degree of inspection or overhaul, the aircrew concerned take over for the test flight. During the test flight, which lasts some 20 minutes, engines, radio, guns, controls, bomb release gear and other parts are subjected to a working test. Finally, the airplane is grounded and, if satisfactory, is ready for bombing up. Bombing up is done in 3 main stages. The first 2 are done by the station armament section, and the third by squadron personnel. The first is the collection of the bombs from the bomb store. The second is the fusing of the bombs at the fusing point. And the third is the loading of the bombs onto the aircraft. We begin at the bomb dump. For obvious reasons, it is far from the hangars and the main buildings of the station. The bomb store is well camouflaged, surrounded by a barbed wire fence, and is guarded at the entrance. Bombing up starts when the detailed orders of the bombs required are received by the NCO in charge of the bomb dump. He passes on these orders to the NCOs in charge of the various bombing up parties, each of which has its own particular task. This party will load the bombs onto the bomb trolleys. First, they put their tin hats and respirators in some place where they can get at them easily. Then they open the bomb store. The bombs are stacked by types. The main types are general purpose, semi-armor piercing, and high-capacity bombs. They range from the 250-pound bomb upwards. Incendiary bombs, because they are incendiary, are stored separately. The bombs used for a particular operation vary according to the kind of target to be attacked. SAP and AP bombs are designed for use against warships and for attacks on heavy machinery. They are strongly made and they have great penetrative power and heavy fragmentation. Here are some GP bombs which have a higher charge-weight ratio. They throw off more but smaller fragments and are therefore used against normal industrial or military targets. These 2 types of bombs have a wide variation of fusing. The GP from instantaneous up to several hours delay, and the SAP from instantaneous up to several seconds delay. HC bombs have a high charge-weight ratio and little fragmentation but heavy blast effect. Because of their light construction, they can only be fused instantaneous. In the store, the bombs are kept apart from their tail assemblies, which are stored in these containers. As a rule, the tail assemblies will be loaded onto a trolley and taken to the fusing point ahead of the bombs. The bombs are lifted from their stacks by overhead gantries, or in some types of bomb dump, by cranes. They are loaded onto bomb trolleys for conveyance between bomb store, fusing point and aircraft. By means of slings, as many as 4 250-pound bombs can be lifted at once. Here you see two 500-pound bombs being handled at the same time and loaded in the same way as the 250-pound bombs. To make for rapid handling of bombs and for the arming and loading of a large tonnage of bombs in a short time, careful maintenance of all bomb handling gear is essential. Larger bombs, such as this 1,000-pound GP, need special slings and tackle. Many of these larger types are not fitted with suspension lugs and are lifted by slings passing round their bellies. Special cradles, too, are needed to adapt trolleys for carrying these heavier bombs. Adequate equipment is supplied to make the loading of larger bombs as simple as the loading of the smaller ones. Here a large high capacity is being moved from the store. These heavier bombs are more easily moved on the gantries by pushing on the load itself rather than by pulling the chain tackle. Before the bomb train moves off, the bombs are securely strapped to the trolley. Transit bases, made either of wood or, as you see here, of metal, may be removed either before the bomb train leaves the store or in dirty weather when it arrives at the fusing point. When the bases are removed, you can see the tail pistols. When all the bombs have been loaded, the bomb trolleys move off from the bomb store to the fusing point. The fusing point, where possible, lies between the bomb store and the aircraft dispersal points. The bomb train carrying the tail assemblies and their containers arrives first. The second bombing out party, who are waiting to fuse the bombs, take the containers from the bomb train. They remove the nose pistols and test them to see that the arming vanes are in working order and the safety devices intact. After testing, safety devices, pins and collars are put back in the pistols. They inspect and test tail assemblies, first removing the safety clip from the arming vane. Here is the safety clip. Its purpose is to prevent the arming vane being rotated before the bomb is dropped. The arming vane is tested for freedom of movement. These boxes contain detonators. They are sensitive to heat and shock and must be handled carefully. Most of the testing of components has been done by the second party, whilst the first party was loading the bombs up in the bomb store. The actual fusing, therefore, starts immediately on the arrival of the bombs at the fusing point. This process usually begins with the tail pistol. The tail pistol is examined to make sure that the arming vane nut and striker move freely. Before the detonators are inserted into the detonator cavity or exploder, this cavity is gauged. The detonator is then inserted into the bomb. Here the process is repeated in close-up. The detonators are kept in position by the tail pistol, which in turn is locked to the bomb by a locating spring clip. Noses of the bombs are fused in a similar way. First the transit plug is removed, then the gauge is inserted in the detonator cavity, and then the detonator. Here again in close-up, the gauge, the detonator, and finally the pistol. The tail assemblies are now clipped onto the bombs. The tails are secured by 4 clips, and the armourer must see that these clips are properly engaged in their respective recesses. It is essential that the operation of clipping on the tail assemblies to the bomb should be correctly carried out. If this is not done, the tails will fall away from the bomb, and the bomb's flight through the air become unstable. Arming vane mechanisms are again checked for freedom of movement. After this test, the safety clip is relocated so that the arming vane is locked. When the NCO in charge is satisfied that all bombs have been properly fused and that safety devices are intact, the train moves off to the aircraft. Another bomb train with a load of incendiary bombs in their boxes arrives at the fusing point. The boxes are unloaded and stacked on one side. These bombs are carried on the aircraft in small bomb containers. Here is one of them being put on the loading cradle. Small bomb containers can be adjusted to take several types of small bomb. The containers are lightly constructed and fragile, so they must be carefully examined before use for distortion and security of releases and partitions. The bomb releases are examined and electrically tested to ensure that the release system is working properly. A canister of 4-pound incendiary bombs is now being unpacked from its wooden box. The lid of the canister is removed and the tin with its contents loaded into one of the 3 positions in the small bomb container. The tin is then secured to the container. The bombs are packed at the factory in such a way that the safety pins are held in position until the bombs fall from the container. They are therefore safe until released. The small bombs are kept in the container by a drop bar, one end of which is hinged and the other end clipped into the bomb release. These drop bars are now being fitted in position. After engagement, the drop bars and bomb releases are tested for security by pulling on the drop bar and moving the cocking piece and the test plunger on the bomb release. The transporter is then clipped onto the container and the container inverted by rolling the loading cradle, which is then removed. Loaded containers are placed on lorries or bomb trains for transport to the aircraft. The bomb train, which here, for the sake of example, is loaded with 4 250s, 2 500s, and 1 1,000-pound bomb, now arrives at the aircraft. The method of hoisting and loading, which you see now, is peculiar to the Wellington. A 1,000-pound GP bomb is now being attached to the carrier. It is suspended from the carrier by a sling, which passes from one side of the carrier underneath the bomb and is then secured to the release slip on the opposite side. This is the 2,000-pound Type A carrier with a single sling. Slings are more often used for heavy bombs, as their weight is too great for them to be suspended by a lug from the normal release slip. After the carrier has been fixed to the bomb, the trolley is manoeuvred so that the bomb is almost exactly under the winch cable. The cable is then attached to the carrier and the whole is hoisted into the aircraft by means of a winch. When the carrier has been located to the bomb beam, the nose and tail steadies are adjusted. This is to stop any tendency of the bomb load moving during flight. The fusing wire is now fixed in position. Small bombs, as well as small bomb containers, are wheeled under the aircraft below the release to which they are to be attached. The bomb release, together with its hoisting cable, is lowered and attached to the bomb suspension lug. One of the crew then winds the winch handles and the bomb is raised to its position in the release slip housing. Others of the party assist by guiding the load carefully to avoid damage to aircraft parts. For reasons of safety, airmen should not get under bombs during this part of the bombing up process. One of the most important details of loading is attaching the fuse setting control links. One end of the link engages in the safety collar of the nose or tail pistol, and the other in the fuse setting control box. A small bomb container with its load of incendiary bombs is now being brought to the aircraft. These small bomb containers are loaded to the aircraft in exactly the same way as a bomb, except that with Wellington aircraft, a special type of adapter is necessary. This can be seen attached to the container. Except for one further important detail, the bombs are now ready for use. Before dark, the armourer must remove the safety pins from the bombs and place them in the correct stowage position in the aircraft. This he should report both to the bomb aimer of the aircraft and to the armament NCO. You have done your part of the job now, and the flying crew will finish it. They will be risking their lives on a task which depends as much on your efficiency, care and skill as it will on theirs.